Hey, it's Todd from One Shot API, and in this video I'm going to show you how to create a Telegram bot in n8n with on-chain features. Some of the topics we're going to get into is setting up a Telegram bot, a brand new one. We're going to cover inline keyboards and callback queries. That's actually one of the reasons I really like Telegram bots, is that you can make really nice user journeys inside of the Telegram Messenger using keyboard flows. We're going to walk through creating a wallet for a specific Telegram user so that only that user can submit transactions from that wallet. We're going to cover data tables for storing wallet and transaction information. Data tables was a new feature added to n8n recently, and it's super useful for creating all kinds of applications in n8n. And then lastly, we're going to cover creating ERC20 tokens from n8n from bot interactions. And this workflow over here that I briefly showed at the beginning of the video, at a glance what this workflow is going to be doing, think of it as like a starting point that you can use to create new bots that do custom things for your users. But this workflow starts by triggering on either a message or a callback query. And anytime you hear me talk about a callback query, think a button click in the bot DM. So it triggers on either a message or a callback, and it's going to switch on whether or not that is a message or a callback. We only want it to respond to start messages. I'm going to show you how to do that. And then it's going to look up users in a data table. So have I seen this user before or not? It's going to look them up. If it's a new user, we create a wallet for them. And if it's an existing user, we send back to them an inline keyboard with the features that they can select to use. So these button clicks result in a callback query which re-trigger the workflow. And then once we're in that callback query branch, we switch on what the action was that the user selected and carry out those actions. So it's kind of a visual aid of what's happening here. Over here on the right hand side, this is a user interacting with the Telegram Messenger, either from a mobile application or the desktop app. And they're going to send commands and callbacks which get picked up by your workflow running in n8n. And then anytime there's an on-chain action or a wallet interaction, those are going to get sent from the One Shot API node to the One Shot API service. And we're going to cover all of that now in this tutorial. So the link to this workflow, I've put it in the YouTube description. So if you click on that link and grab this workflow, open up n8n, create a blank workflow, and paste it in the user interface, you should see something like this. What we want to start with is Telegram. This is a Telegram-centric template. And so let's just click on the trigger here to start with. We need a bot to connect to. So if you click on this and hit create a new credential, you need the access token from your bot. So let's start by doing that. If you open Telegram and you search for the bot father, the bot father is where you start with creating new bots. Type in new bot, hit new bot, and follow the directions to get one created. And then I like to open the bot father user interface here. It makes it a lot easier to configure things. If you click on that user interface, you can copy your access token here at the top. Copy that, paste that into your access token slot here and hit save. And then all of your Telegram nodes will be able to communicate with your new bot. We have a few other things we need to set up though for this tutorial. We need a command, so let's click on commands, and you want to create a start command for this workflow. So if you hit add a command, type in start for the command, give it whatever description makes sense for you. And then for this workflow, you want to disable group chats and group administrators. We don't need those two. We're tying user wallets to a chat ID because chat IDs are immutable and usernames can be changed, and sometimes Telegram users don't even have usernames. So we're going to be tying user wallets to chat IDs, so we don't want our bot responding to group messages. So disable group chats. And then lastly, back over here in bot settings, just to lock things down a little bit, we don't need admin rights or channel rights. Toggle those off, and then toggle off allow groups And at that point, our bot setup in Telegram is done. So we've got our API key, we've got our command, and we've limited commands to just DMs. We can close the bot file now, and if we come back to our workflow, we're authenticated for responding to messages from Telegram. So this first node here, this trigger node, you can see here it only triggers on messages and callback queries. And if you open this up, there's lots of different things you can trigger on depending on what you want your bot to do. But for this simple tutorial that's just showing you some patterns for creating on-chain bots, we're just doing messages and callback queries. And first thing is we filter on whether it is a message or a callback query. If it's a callback query, it means the user has clicked a button, and we go through this upper path. If it is a message, first we make sure that the message is a start command. That's this if block right here. If it's not the start command, we just ignore it, so that if somebody sends, gibberish to our bot, it doesn't respond to it. And if they send the start command, we want it to send them back a message. So this bottom flow here, this is your primary user interaction when a user finds your bot and starts interacting with it. And we look up the user in a data table. So we're using data tables in this workflow. And the first thing we do is we say, okay, in our user data table, I'm going to show you how to make that in just a second. We search on the chat ID column if we've seen that chat ID before. And so if we haven't seen that chat ID before, that means it is a new user. And we go through the wallet creation flow. And if we do have that chat ID recorded in our user table, we send them back their balance, which you saw here. It found my wallet and it says I have a little bit of tokens in that wallet. So let's create that data table before we get too far into this. So let's come back to the n8n portal. Let's click on data tables. And for this tutorial, we need two data tables. The first one, click create a data table. The first one, call it user table. And it needs these three columns added to it. It needs a chat ID column. It needs a wallet column. And it needs a wallet ID column. So add those three columns. And then while we're over here, go ahead and create this second table, token table. And inside the token table, you need these four columns. You need a wallet column, a token column, a name column, and a chat ID column. So this is where we're going to record the ERC20 tokens that are deployed by this workflow from users. So once we've got those two data tables created, we can come back to our workflow and let's look at a user account creation branch down here. So creating a user wallet, I kind of consider that as like creating them an account. So it will need to interact with OneShot API. So if we open this, create a new credential, and for the credential, log into OneShot API, create a free account if you don't have one already. And let's come down here to the API keys tab, hit create a new key, give it a name, and that's going to give you a key and a secret. So you'll need those two things as well as this business ID up here in the top right hand corner. And key and secret go here. Scroll down a little bit, business ID goes here. Hit save, and now your OneShot API nodes will be authenticated against your developer account. So let's take a look at this creating a wallet node. And if you search for OneShot in the node selector over here, if you scroll down to the bottom, we're using this create a wallet action. So that's what this node is here. And if you're running your own n8n instance, you might need to install the verified community node from OneShot API. I put a link in the YouTube description for how to do that. If you're running an n8n cloud, it should show up as it is a verified node and should be available in the cloud option. So we're going to name the wallet based on the chat ID of the user DM. So those chat IDs are unique and they're immutable, so they're not going to change, and that's why I like to use chat IDs for identifying a specific user. And then we give it a description as well. So whenever a user creates a wallet by interacting with your bot, back in One-Shot API, if you come to the Wallets tab, as more users start to interact with your bot, you'll see wallets getting created over here. And so One-Shot API doesn't charge for additional wallets. You can have as many wallets as you want, hundreds, thousands of wallets. But you'll see here, here's my wallet that I created by interacting with the bot. That's my chat ID. The description has my user name in it as well. So if I want to search for a user, maybe they're having problems, they contacted me, they need help, you can come to the search field and search for the user wallet to see what's going on. That's kind of helpful there. You can see I'm doing this on Binance Testnet. You can change these nodes here for the target chain to whatever mainnet makes sense for your application. So we create them a wallet by naming it after their chat ID. Then we record that user wallet. We link the wallet address to the chat ID. And then we also record the wallet ID. So this is actually a One-Shot API variable. So back over here in One-Shot API, if I click on my wallet here, this is your wallet ID. That's what we're recording in the user data table. So once we record those in that user data table, we send back the user information about their account that just created. We send them back the wallet address, and then you can customize this message to say other things as well. But we send it back to the chat ID that initially triggered the workflow. So that's a good pattern just to kind of get in your head, is that I can create as many wallets as I want from my One-Shot API developer account, and I link them to a specific user in the Telegram Messenger via either their chat ID, which I recommend, again, because it's immutable, and it's going to be one chat ID per DM. Be sure to disable group messages so that you don't get wonky behavior. But you can also use usernames as well. Just be aware that if you use usernames, you need to handle the case where the user hasn't set their username or maybe changes their username. And so if we come through here and we detect this, this is a user with an existing account, we use the list wallets operation on that chat ID, because remember we named it after the chat ID, so we can look it up based on a name fragment. And this will return us the current balance that the user has in that wallet. So in this final message node in this branch, we say your wallet address is whatever the address is, and it has whatever One-Shot API looks up as their current balance of that wallet. So you can see that here whenever I invoke the bot, it finds my account address and it says I've got some testnet BNB in that address. Now, an important thing about this node, if you look at it more closely, we're using reply markup, and there's different reply markups you can put on your messages. This one is using the inline keyboard, so this is a super useful tool for creating Telegram bots. This is how we add buttons. So these buttons you see here in this message come from this reply markup. And we've got two rows. Here's the first row, and here's the second row. And it's very easy to create buttons. You give the button a name, and then you need to give it a callback data field. So this is what we're going to select on in the other branch of the workflow. So we can select on creating a token, sending tokens, and then down here I've got this other button, list the tokens that I've already deployed from my account. So those are the buttons that we've added to this template workflow, and then this callback data is what we're then going to switch on. So when I click one of these buttons, let's say see my tokens, that triggers the workflow via a callback query. So this callback query will send us to this upper branch. Again, we look up the user. At this point, if we've ended up in the callback query, the user must have an account in order to get to this point. So we look them up, and we switch on which one of the actions that they chose. So you can see here, the callback query data. Did they choose create tokens, send tokens, or list tokens? And so that example I just did, I said see my tokens, which is a listing operation. So here's where we hit the token table and we search on the chat ID, and for the value we use the chat ID and we convert it to a string. Because the chat IDs are numbers, you'll need to convert it to a string in order for this to work. And so if they have tokens, we have a little bit of JavaScript here we use to construct a message, and then we send that list back to them, and then that's what you see here in the bot response. So we haven't done anything on chain yet, so we'll do that next. We're going to deploy a token now. So we want to select the create token option. So for the create token option, we're using One-Shot API to send a transaction to the blockchain to deploy an ERC20 token. And for that, we're using One-Shot API execute. And specifically, you can execute transactions either asynchronously, meaning I tell One-Shot API, send this transaction and then return immediately. Don't wait for the transaction to be confirmed. And there's also the submit and wait option. I'm using the submit and wait option so that I get back information about the token that was deployed. So when I run this in submit and wait mode, I'll actually get back in the transaction logs information about the token. So if I look at this node, first thing is I'm using the wallet ID of the person that asked for the token to be deployed. So that's why I'm using this wallet ID field. So if you click on this, there's other things you can add here. I'm using wallet ID to submit the transaction from the user's wallet. So if the user doesn't have any tokens in their wallet, anything to pay for gas, this transaction will fail and will send the user a failure message to check whether or not they have tokens in their wallet. And then I also put a memo field on here so that if I'm looking at my bot activity in my One-Shot API developer platform, I can see the memo field of what's going on from my bot from the memo fields. Now, to deploy tokens, I'm using this little project that I've put together for One-Shot API users. It's called the One-Shot Token Factory. It's just a simple smart contract project that only has 2 smart contracts in it. It's got a very simple token factory contract, which is what we're interacting with, and it has a token implementation. So back over here, this is just a standard ERC20 token. It takes a admin account. So this is going to be the user's wallet that pays to deploy it. Their wallet will have the admin role, which means that they can mint new tokens from their token contract. It has the name and the ticker symbol for the token, and then the max supply that the token can have. So like 1 million tokens or 100 million tokens or whatever the user decides for their max supply of their token. So if you want to use this token factory, you're free to clone it, modify it how you want, and deploy it to any of the networks. It's all set up to do that, but we're using this One-Shot Token Factory, and we're using the Binance Smart Chain Testnet deployment. So we're using this smart contract that's already deployed. So we need to import this into our developer account on One-Shot API first. So if you grab that contract address on Binance Smart Chain Testnet and come back over to One-Shot API and go to My Smart Contracts, hit Import Smart Contract Methods, paste that address here, point it at Binance Testnet, and then hit Fetch Contract API. And the only function you need to import is this deploy token function. So if you click on that and hit Add to My Contract Methods, hit Create, that will add it to your methods that you can then call. And so we're calling this deploy token method, which takes an admin, a name, a ticker, and this one's called pre-mint, but that pre-mint is actually your max supply. So back over here on this deploy token node, you can see here we've got admin, name, ticker, and pre-mint, and we fill them out with expressions that come from these 4 previous nodes where we ask the user what do you want to name the token, what do you want its symbol to be, and what do you want the max supply to be. And you can see here we're calling the deploy token method here from our function selector. And then once that transaction completes, we record from that transaction the wallet address that sent it, so that's the user's wallet address. We record the token address, which comes from the transaction logs output by One-Shot API, the name that the user chose to give it, and then the chat ID. So we can use these for looking up the token later on. And then we send the user a confirmation message that their token was deployed and where it was deployed to. And if this transaction fails for some reason, like the user doesn't have any gas, we send them a failure message to start again, and you can customize this message for your application. Let's see it in action. So if we open our bot and we choose create a token, so you can see here this has a wait for response. These nodes here are a send and wait for response node from Telegram. So we'll say respond, which will open a web view, name it whatever we want. It'll send me another message. What do you want the token symbol to be? And then lastly, how many tokens do I want to be the max supply? And I'll just say I want 1 million. And then it'll say it's creating the token, and then it deployed it. And if we come back to One-Shot API, go to transaction history, there's the transaction that was just submitted for the user from your n8n workflow for your Telegram bot. And now if I were to ask the bot, see my tokens, there's that token that I just launched, and it looked that up from the data table. The token information was recorded in the data table. So the last thing here is we want to be able to send some tokens. So that's the last pattern I want to go through. Over here, this One-Shot node is doing something that's slightly advanced. Again, we're running the transaction from the user's wallet, and we're doing a contract address override. So in One-Shot API, the typical flow is I import a smart contract method for a specific smart contract. But if I'm letting users deploy their own tokens, I don't want to sit here and import the mint function for every single token that every user deploys, because every single one of these tokens is using the same token implementation, which is this implementation right here. So what I want to do is take this address, import a single function, again from my smart contracts, import that address on Binance testnet, fetch the contract ABI, and we want the mint function. So if I add that to my smart contracts, you'll see this mint function here. I want the user's wallet to call this function, but I want them to call it on the user's token address. So this contract address override allows you to call the mint function, but instead of calling it on the implementation contract address, it's actually getting called on the deployment address. So that is what this contract address override field does. So that's kind of an advanced feature of One-Shot API, but I wanted to call that out in this tutorial. So we're using the user's wallet on the user's token address. We're calling mint. Mint takes a to and an amount. So there's your to address and then the amount, and I'm just automatically appending the 18 zeros for the decimal places of the ERC20 token, so I don't make the user type out 18 zeros in their response. That submits this transaction and then sends the user back once it's deployed, or once the tokens are sent. It sends them their transaction hash, and that transaction hash comes from the One-Shot API node. So if we run this now in our Telegram bot, we can say send some tokens. I'm going to send that token that I just deployed. So which token do I want to send? I want to send that token. How many tokens do I want to send? I'm going to send 100. And then lastly, it's going to ask what address do you want to send the tokens to. So if I open that, I'll just copy this address here, paste it here, submit, and that will initiate the new transaction. And then it sends me the token sent transaction hash. So if I copy that transaction hash and put it in my block explorer, there's that transaction. So that pretty much covers some solid patterns that you can use for building on-chain features into your Telegram bots that you are building in n8n. I really recommend using inline keyboards for users to narrow down actions they want to take in your Telegram bot. And then the most important pattern is how to create wallets for your users and tie them to a specific user so that other users can't accidentally access a different user's wallet. And then we talked about using data tables so that when a user wants to submit transactions from their wallet, we can leverage those data tables to look up the one-shot API wallet ID and then send transactions from that specific user's wallet using wallet overrides and then also using contract address overrides. So give that a shot. Check out this Telegram bot template. If you have questions, reach out to us in our Telegram group, and watch out for other tutorials on YouTube coming from us soon.